Welcome to Math Ninja Academy. In today's session, we're going to be strictly focused on what we call ODE. The word ODE is an acronym for ordinary differential equation, meaning that we'll be dealing with ordinary differential equation. The word ordinary differential equation simply means that we're dealing with an equation which consists of dy over dx, which is equals to f of x, and f of x can only be a function of one variable. So there are different methods that we can actually use to solve this type of ordinary differential equations. In TET, the ones which are prescribed is direct integration, separation of variable, and more. But in this session, we are strictly going to focus on the basics on how to solve ODEs, which is ordinary differential equation, using direct integration and separation of variable. So let's start with our first one, which is direct integration. Direct integration. The first thing that we need to do is to go beyond theory of direct integration. What do we need to know? We need to know the standard form of direct integration. We have our standard form, which is given by dy over dx to the exponent n, which is equals to f of x. This is the standard form of direct integration, and you must know that our f of x is actually a function of one variable, and the most important part, you should also know that the coefficient of the derivative must always be one, meaning that if you had to solve this type of problem and you are having a constant or any function, you need to divide by that function. So this is basically summarize the standard form of direct integration. Okay, now we are familiar with the standard form of direct integration. What next do we need to know? We need to know the method behind direct integration. What exactly am I referring to when I say method? When I say method, I'm basically referring to how do you solve these type of problems when you're having direct integration. So for example, if you were given a problem and they say use direct integration, so you need to know the method that you're going to implement for you to be able to solve that type of problem. So the method is that it's simple. You just integrate n 10. So n can be anything. N can be anything. N can be equals to 1, n can be equals to 2, or n can be equals to 3. If you look at our standard form of direct integration, you can see that we have d to the exponent n dy over dx. This n here actually represent the degree of our ODE. So if you are having a first order differential equation, if you are having a first order, it means you integrate once. If you are having a second order, it means you integrate twice. Please keep that in mind. Let's quickly do an example. Let's say maybe you have dy over dx, which is equals to x, for example, and then we can easily see that this is direct integration. Why? Number one, we have function of one variable. We can quickly see that this is direct integration because we have function of one variable. And what else can we identify? We can see that this is the first order. The exponent here is 1. So it means n is equals to 1. So how do you solve that? We're going to say y is equals the integral of x dx. Since it's the first order n is equals to y, it means that we're going to do what? We're going to integrate once. As I said, the method will integrate n times, so we're going to integrate once. So it means our answer is going to be x squared all over 2 plus c, and then this is your final answer. Y is equals to x squared over 2 plus c. Note that this is what we call a general solution. This is what we call a general solution. Why? Because it consists of the variable c, the integrating constant. At some point, you will be given some condition. Let's say, for example, y of 0 is equals to 3. It means that y is equals to 3 when x is equals to 0. And then you can get the value of c using this condition. So this summarize direct integration. Let's move to the second one.